Hi friends, welcome back. In this video, we are going to discuss about cross data center replication, also called XDCR. We are going to discuss all these things, a walkthrough on high availability on XDCR, XDCR use cases, discuss conflict resolution, how to set up XDCR from Web UI, CLI, and REST API. We will discuss XDCR additional use cases. Basically, Couchbase supports high availability and disaster recovery. High availability features are zero downtime administration and maintenance, like OS patching, Couchbase patching, and upgradation activities, data redundancy, and automatic failover. Disaster recovery is nothing but a plan for business continuity for mission critical applications. For DR, one or more clusters can be act as hot standbys. For example, we can have a replica of our production cluster as standby and create XDCR between these two clusters. So when a code change is happening in the production cluster, we will stop the replication between active and standby clusters and push the code change to the active cluster and will thoroughly test it. Once everything is validated and looking as expected, we will resume the replication. In case during this activity if something goes wrong, we have our standby cluster. We can simply route the traffic to the standby cluster, or in case required, we can also recover our active cluster by using standby cluster. In case of serious failures, XDCR can also be used to recover data from the remote cluster, backup and restore in the worst case scenario. This is the write request workflow in Couchbase. When application writes a document, it will come to the cache. From cache, it will go to the disk queue. From there, it will be written to the disk. Parallelly, it will also push this document from cache to replication queue, which will copy the document internally to the other Couchbase nodes in the same cluster. It will also send the document copy to XDCR queue if there is any replication configured to any of the remote clusters. XDCR use cases deliver high-performing async data replication, provides a disaster recovery, and support various topologies and replication schemes. Like we can configure fully secure XDCR or half-secure XDCR. We will see that in few minutes how to do that. Use filtering to replicate only specific set of documents. Suppose if a bucket is having 100 documents and we need only 20 documents that are starting with any specific keyword, we can give that keyword in the filter condition. We will see how to do that in few minutes. Easy setup of development and test environments. For example, I have a dev cluster. I need exact same copy. I will create an empty cluster with the desired number of nodes, and I will also create required buckets, and then I will configure XDCR from dev cluster buckets to test cluster buckets. No need to take any backup dump on the dev cluster and transfer the dump to the target test cluster. We can simply create XDCR which will copy the document from dev cluster to test cluster. Firewall should be open between the dev and test clusters to set up the XDCR. Quickly refresh the buckets in dev and test environments. Just like I said now, we can refresh the buckets also. Suppose I want to copy a bucket from dev cluster to test cluster. I will go to the test cluster. Depending on my use case, I will flush the bucket in the test environment and will create replication from dev bucket to test bucket. Key features of XDCR: conflict resolution. If we have master setup, suppose same document is updated in both clusters, then conflict resolution comes into picture. Transfer and security. We can transfer using half SSL or full SSL. Administrative interface. We can administer XDCR from Web UI, REST API, as well as CLI commands. Continuous asynchronous replication. XDCR can be created per bucket. If you have 3 buckets in your cluster and you need replication for all buckets, you can create 3 replications. Or if you want only 1 bucket replication, you can create 1 replication. It's memory to memory. We can create multiple replications. Replication evenly load balanced across all servers in the destination cluster. In case replication is stopped due to any issue, it will be resumed automatically. It's a push-based replication. Compares revisions hash before transfer. For example, if I have created replication for a bucket in dev cluster to the test cluster, my test cluster bucket already has few documents that are there in the dev bucket. Before initiating the transfer, it will check the revisions hash for the existing documents. Source tracks what destination last received via checkpoints.